Hi folks, welcome back to Physics with Captain Rod. Let's go through some energy cost examples. So example 1, let's see. Calculate the cost to leave on 6 bulbs at 50 watts each for a month using 20 cents per kilowatt hour. All right, just a little side note here. 20 cents a kilowatt hour has been what my bills have been as of late. When I first started teaching physics, it used to be about 8 cents a kilowatt hour, but such is inflation in our lives. All right, so hopefully it's reasonably obvious that if we have 6 bulbs, 50 watts each, the total power output is 300 watts. And that's 0.3 kilowatts. Because remember, a kilo means 1,000. Now, to get our energy usage, we need to multiply that by time. Right? So we got 0.3 kilowatt times, now we're going to multiply by the number of hours in a month. So let's use 30 days times 24 hours per day. And if we multiply this all out, I get 216 kilowatt hour. All right, now to get our cost, 216 kilowatt hour times. Now this is going to come out into dollars, obviously, so why don't we use, instead of 20 cents per kilowatt hour, let's use $0.2 per kilowatt hour. And out comes $43.20. Okay, don't leave those lights on. All right, next, example 2, and this one's a little more involved. Calculate the cost in electricity to run an electrical resistance heater and provide the same heat as a gallon of propane, assuming the propane heater is 80% efficient and the electric heat is 100% efficient. All right, so I went ahead and already looked up a couple of values to save us a little time. Propane has about 91,452 BTUs per gallon. And I also looked up the conversion factor here to convert BTUs to joules. So if we do that conversion, give me just a moment. 1, 2, 3, 4, 5, 6, 7. Okay, I get 9.65 times 10 to the 7th joules. And if you don't mind, I'm just going to look this over again. Yeah, okay. Now, this is how much energy there is in joules available via combustion in a gallon of propane. Now let's deal with this 80% part. So efficiency, remember, is output over input. I'll put energy out divided by energy in. Now, as far as the furnace is concerned, okay, a gallon of propane, this is the energy going into the furnace, and then this, the energy out, is the energy going into the room. So this is going to read 0.8 equals our energy out, which is unknown, divided by our energy in, which is 9.65 times 10 to the 7th joules. So our energy out, give me a moment, is 7.72 times 10 to the 7th joules. That's a point here. Now, hopefully this makes sense based on the efficiency that, you know, we're going to get less energy into the room than is coming into the furnace. All right, so now let's deal with the electric heater. If we were using electric heat to get this amount of energy, so we got 7.72 times 10 to the 7th joules. We're going to, let's convert this to kilowatt hours, because that's how we're charged by in the kilowatt hour, or we're charged by the kilowatt hour for electrical use. The conversion factor is in 1 kilowatt hour, there is 3.6 times 10 to the 6th joules. Now, here's how I always remember this instead of having to look it up. Kilo means 1,000, so 1,000. Watt means joule per second, and an hour is 3,600 seconds. That is where this is coming from. All right, anyway, we don't need this anymore. So let me see what we get out of that. Okay, I got 21.4 kilowatt hour. Now we're going to take 21.4 kilowatt hour and multiply by 20 cents per kilowatt hour. And I get $1.07. Whoops, something's not quite right with this. Give me just a moment here. I'm sorry, I get 428, or in other words, let me write this in dollars, $4.28. That's what I get out of that. Okay, now let's discuss this for a little bit. And particularly, let's put some cost in here now. So propane, my last bill, I think I paid around $2.50 a gallon. And the equivalent electrical cost is about $4.28 a gallon. This is why electricity is not the primary fuel heat source in most houses. Most houses have some sort of fossil fuel type of heat source, either propane or wood or natural gas or something like that. Usually pure electrical resistance heating is the most expensive way to heat a house, or heat your hot water, or et cetera, et cetera, et cetera. Now, there are ways to heat using electricity that are much cheaper by using what are called heat pumps. And we're going to talk about those a little bit later in the semester, so I'm not going to worry about that now, actually, in just a week or two. But for now, the point of this problem is, one, to give you, some little bit of experience in how to do some of these calculations, and two, to recognize, propane typically is quite a bit more cheaper than burning or using electrical heat, and that's why most houses don't have electrical resistance heaters. So let me see if there's another example after this. Nope, that's it. All right, so I hope you enjoyed the video. Have a great day.